Yesterday, I introduced the concept of I introduced you to the contrast. I introduced the concept of inheritance in object-oriented programming languages, and we have seen one example of inheritance implementation in C++. Today, we will continue our discussion on the inheritance. We will see more details. The details will not come in terms of C++ notation, but it will be in terms of general object-oriented programming language ideas. Okay. And while we are talking about inheritance, of course, we will be using lots of other techniques that we have learned about object-oriented programming. So this is kind of a nice review of what we have learned so far and introduction of a new concept. Okay. So the idea of inheritance, as we said yesterday, we define a general form of a class, such as an employee class. Employee is a very general class, actually. I mean, there shouldn't be a employee class because it is too generic. It is too general. Because other than name and social security number, I cannot say anything about it. Okay. So it is a very general type of class. We don't write the employee class to use it, okay? But later we use the employee class to do inheritance, to do derivation, okay? When we start deriving new classes from the employee class, it makes sense, okay? So yesterday what we did was this employee class. It has nice set name, get name stuff and pay stuff, but we didn't know how to print the check. That's why we said that whoever calls this print check will be terminated. So it looks like our intention is not to use the objects of this class, okay? But we are going to use this class for deriving other classes such as the salaried employee. Okay, salaried employee says that I am an employee actually here. The meaning of line 14 is this. I am an employee actually, but I have additional features such as the salary. Okay, since I know the salary now, salary is how much I am making per week. Okay, now my net pay is known. Okay, so I can implement nicely this print check function, and that will be a very solid class, salaried employee, and I can use objects of it. Similarly, let's say I have another class idea, hourly employee. Here it is. Hourly employee is an employee who gets paid by the hours. Let's say I have worked 10 hours this week, and for each hour they pay me 50 Turkish liras. So my net pay is going to be 10 times 50, okay, which is 500 Turkish liras for that week. So hourly employee is very similar to employee, but it has more stuff like how much I am making per hour, okay. So this is a wage rate, and how many hours I have worked. Other than that, it is a set name, get name, set SSN, get SSN, and get net pay. They are all the same as the employee class. That's why I say that I am the same as employee, but I will introduce some other stuff. So if I go back and if I update, remember my nice picture here, let me, okay, so trying to fix the pen problem again. Reboot the pen. Okay. So another arrow here, and this time it is hourly employee, and within this class hourly employee, I am going to do this. Okay, two parts. For the privates, I have a wage rate, which is a double, and I have hours, again another double, and of course I have my hourly employee constructor, another hourly employee constructor. This one takes the string for the name, string, another string for the SSN, and hours, and it will take wage rate. So it will take 4 parameters. Then I have set get hours and set get wage rate. So of course these are all pluses, plus, I forgot to put this print check, of course. Because print check is going to be redefined. Okay, so this is going to be my new picture now, as you see. Okay, this is going to be my picture, a nice hierarchy. Okay, a nice hierarchy. At the top I have this employee, the base class. I have another derived class, salaried employee, another derived class, hourly employee. As you see, although my intention was not to use the employee objects at all, employee becomes a very useful class. Why? Because it forms a general base class. It includes all the nice code about getting and setting names of the employees and the social security numbers and that kind of stuff. Even though my intention is not to use any objects of it, it becomes very useful to make two new classes, salaried employee and hourly employee. Okay, and I can go on and on, right? I can add more stuff like maybe a commission employee. An employee makes his money by the amount he sells. Okay, let's say I sold 1,000 Turkish liras worth of goods. Okay, I am getting 5% of it, so I will make 50 Turkish liras, right? So the commission employee works that way. So print check is going to be different, but the rest of the stuff, like the names and the other stuff, is going to be the same as the employee. So employee, as the name implies, okay, is a base class, okay, and it is going to serve us as a starting point, general, okay, it's a general form of the class, and later we add specialized version of this employee. And this may seem like a nice idea, but it may not be very useful in the real life. It is not, actually. We use this a lot in many places. We use this a lot in many places, and you're gonna see it in several places, especially with the other object-oriented programming languages such as Java. Java uses this hierarchy thing in a very often, in a very abundant way. Let me show you, in fact, the Java collection hierarchy. Okay. So this is let's ignore the colors for now. That will make sense later. Okay. It says that at the top I have an iterable class, then I have the collection from this list derives, and then I have my array list, linked list, vector, and stack. This vector is very similar to C++ vector. Okay. And trees, you know about the trees. Trees are using the class set as a base class. Okay, so all the classes are related, and this is the most general class, iterable, at the top. Okay, stack says that I am same as vector, I have only additional this and this and this and that. Okay, hash set says that I am a set actually, but I have additionally this and this. Okay, so this is actually a simplified picture of the Java collections hierarchy. This is the standard library of Java, by the way. You could say it that way. This is a simplified version. The real version is much more complicated and detailed. And there are like 100 class in the hierarchy, Java collections hierarchy. Okay, so this idea is not a small novel idea that never used. It is used frequently, very often. It is very popular, and we will try to use this idea of inheritance a lot because this is one of the fundamentals of object-oriented programming. Write the general form of a class and later derive specialized versions of it. Again, this is an example of code reuse. Why? Because each of these classes, salaried employee and hourly employee, is reusing this class employee's code. Okay, good. So we talked about this terminology, base class and derived classes. Okay, employee, let's look at this class employee, remember. Okay, actually, I mean, in my world, there are two types of employees. Salaried employees who are get paid weekly. Every week I pay them 500 Turkish liras. And there are hourly employees. And these employees get paid by the hours they work. Okay? Two types of employees. But I know that there are many common stuff between these two employee types, such as the social security number, set name, get name, etc. Okay? So each is a subset of employee. So what the idea is, let's write an employee class. Although I am not going to use objects of employee class at all, it will be a nice general class, and I will derive from this class, and I don't have to copy and paste. Lots of stuff between these classes. Okay, so our employee is kind of a generic class, a common class. Good, we talked about this. Employee class is very simple, and my intention is not to create objects of this class, although I can, but they will not be very useful because why? When I call the print check function, it will terminate my program. So I don't like that, of course. Okay, so this one talks about the print check function. Okay, so derivation from an employee class is a term. We use this with all the object-oriented programming languages. Derivation. Okay, I derive classes from the employee class, and the new derived classes will have automatically all the member variables of the base class and all the member functions of the base class. Okay, and this operation is called inheritance. The derived class said to inherit members from a base class. Okay, then I can redefine existing members or add new members. Okay, so this I have to be careful here. Redefinition works only for function members. You don't redefine the data members, okay? There is no redefinition of data members. You only redefine the function members of the base class, such as the print check. But we can freely add new function or data members. And we did that, okay? We did that in this case. Let's look at the hourly employee class. Hourly employee adds 2 new data members. Okay, it has 2 new data members, and it adds 1, 2, 3, 4 function members, and it redefines this line 24 print check. Okay, so that's the reflection of those things on that slide to this concrete code. Okay, good. Are there any questions about what we said so far? As I said before, I am not giving you any new syntax-based stuff. The only thing that I showed you is this, right? Other than that, I didn't show you anything new about the syntax. Maybe if you look at the implementation of this hourly employee class, maybe this is kind of, well, it is not that new because the member initialization, we are saying that we are initializing the base classes objects within the hourly employee. And other than that, I didn't give you much new syntax. Syntax is very similar to what we have been doing, okay? But idea is very, very new, okay? That's why I am not going to show you much code. The code is going to be like that. Okay. So the book, just the slides are going over the code that I showed you. Hourly employee, of course, and I am doing this. Okay. I don't like how print check works. I am going to change it. That's what they say. Okay, good. So the hourly employee class interface is, of course, it's like a regular interface. I have my guards against multiple inclusions, and I include, of course, I have to include this one. This is important. I have to include employee.age. Otherwise, the compiler would not know about this one, right? I have to include employee.age. Why am I including this string? Because I am using this strings there. Okay, good. And it goes like that. And there is nothing much new about the usage of the C++ syntax. Okay, as I said before, the derived class only says that these are new functions and data members, and these are the redefinition of the functions, and that's it. That's it. Okay, so hourly employee adds the constructors, wage rate, and hours, and of course I provide the setters and getters for these new data members if it is needed. Remember, the rule is if it is needed, you add these setters and getters. You don't add them automatically. Okay, and the redefinition print check. Well, the book says it is override. Sometimes people use this term override for the redefinition, sometimes. But override is a more specific word. And we are going to see the difference between redefinition and overriding. Okay? And let's ignore this word for now. But if you see it, think it as redefinition. Overriding is a little bit different. It's a form of redefinition, but it is used in some other context. We will see it later. But if you see this term, you think of it as redefinition for now. Okay, so new and redefined stuff will go in there. Okay, let's look at some more inheritance terminology. This inheritance terminology is standard among the object-oriented programming languages, And usually we draw stuff like this. Let's say I have a base class A, okay, and I am driving class B, and I am driving C and D. By the way, this is possible too. In C++, this is possible. This is called, this class E is using multiple inheritance. Okay, multiple inheritance. And it is sometimes, if you are careful, very useful. Okay, we will see. There are some problems with it, but it will be very useful for some cases, and we are gonna see it. Okay, so let's look at this terminology. A is parent of B and C. Okay, so A is a base class, and we call them A is the parent of B and C. B ile C'nin ebeveyni. A in Turkish. Okay, and B and C are child classes of A. B and C are children of A. Okay, and there is this relationship of ancestorship and descendantship. Okay, A is the ancestor of B, C, E, D. Okay, so you don't, A is not the parent of E and D, it is the ancestor of E and D and B and C. Maybe in Turkish you would call it Ceddi. Can we say Ceddi in Turkish? Sometimes we say dedesinin dedesi kind of stuff. Geçmişi. Okay, so A is the ancestor of B, C, E, D. Okay, and descendant, all B, C, E, D are the, okay, all B, C, E, D are the descendants of class A. Okay, so bunun sülalesinden gelenler mi deriz Türkçe'de bilmiyorum. Okay, so descendant class, opposite of the ancestor. So these are some terminology. As you see, these are all derived from the human hierarchies or the human family trees. You know, I mean, in family trees, you define this kind of stuff. Sometimes they say that the Ottoman Empire family tree, you see that, and you see these kind of arrows shown between the sultans. This is kind of that. And while we are talking about the human inheritance is very different from object-oriented inheritance, actually. And it's kind of unlucky to give them the same name, inheritance, to both of them. In human inheritance, when you do an inheritance from A, such as B inherits from A, right? When B inherits from A is dead. A is not living anymore. Okay? A is dead. A is not living anymore. But in object-oriented programming languages, A is well and alive. I could use objects of A. It's a nice, healthy class, no problem. And when the inheritance happens, these descendants, they share the inheritance, right? They share it. In this case, for the software object-oriented programming language world, there is no sharing, okay? Both B and C inherit whatever the A has, exactly the same, okay? Let's look at the code and let's look at it again. Let's try to see. See, this is the base class, employee. Employee doesn't know anything about inheritance. Okay, it doesn't know that class hourly employee and class salaried employee will inherit from it. Okay, it doesn't know anything about that. Class employee. So employee thinks that it is a one nice isolated class. Okay. Inheritance is known only by this hourly employee. Hourly employee says that I will derive from employee. So hourly employee, of course, has to know about the employee, and it says that I will inherit whatever it has. And salaried employee is saying the exactly same thing. I will inherit from employee. But these two classes, hourly employee and salaried employee, they don't know anything about each other. They don't know that salaried employee is and hourly employee are siblings. Okay, they derive from the same class. They don't know. I mean, in the code we don't see it. Okay, so B knows that it derives from A, but B doesn't know that C is deriving from the same class. The code doesn't reflect it. So these are kind of differences between the human inheritance and the software object-oriented programming world inheritance. They are very, very different concepts actually. And so the name is kind of unfortunate. The name is very, very, maybe the name is kind of unfortunate. Maybe the hierarchy is a better term, because this is really a hierarchy, because we say that this is the most general one. Remember the picture that I showed you before? The picture that I showed you before about the motor vehicles. Where is it? Did I draw it? Did I draw it in the first page? Yeah. Okay. This is a hierarchy. Okay, this is correct. This is the most general class, and these are the specific classes. Okay, motorcycle is a specialized motor vehicle. Automobile is a specialized motor vehicle. Convertible automobile is a specialized automobile. Okay. So these kind of hierarchies are very common. And in real life and in object-oriented world, we can form these kind of hierarchies ourselves too. Okay, good. Okay, so let's continue and let's talk about C++ inheritance a little bit more. As I said before, I am not going to introduce much new syntax, but there are many points, detailed points that need to be careful about the inheritance in C++. One of them is the constructors. Okay, base class constructors are not directly inherited in the derived classes. That's why we write our own constructors in the new derived classes. Okay, there are certain functions, there are certain things that are not inherited. Let me try to give you the list. Where is my list? The list is here. Okay. These functions are not inherited directly. Okay, by inherited, I don't mean that they are not available. They are available, but they are not inherited directly. The constructors are not inherited. The destructors are not inherited directly. Copy constructors and assignment operators. Remember, if you don't define any of these, compiler will make a default one for you, right? So if there is a default version of it, if you like to remember these, okay, they are not inherited. You have to write these yourself because they will not be directly inherited. They will not be directly inherited by the inheritance. Okay, so what did I say? There are certain details that we need to be careful about, and this is what I This is what I mean. Okay. Constructor-derived classes, they are not directly inherited, but we can invoke them. Okay, we can invoke them. So, I mean, this sentence is not exactly correct, because if they are not inherited, how come I can use them? Of course, they are inherited, but they are not directly inherited. I mean, base classes constructor doesn't become my constructor. If you look at the interface here, salary the employee has to have its own constructor. Base class employees constructor cannot be my constructor because it is constructing some other class's object. That's not powerful enough for me because I need to initialize some other stuff such as the salary, right? So the base classes constructor is not my constructor. I have to write my own constructor, but while I am writing my own constructor, I am using the base classes constructor here. And this is what I should do. Okay, and I will do exactly the same thing with the copy constructors because I need to write the copy constructor and the assignment operators. In this case, for this hierarchy of employees, I didn't write the big three, right? I didn't write the big three. Why? Because big three is not needed. I don't have any pointers. Member-wise copy, the default meaning of the assignment and the copy constructor is okay. That's why I didn't write any of them. Okay, so the although copy constructor and assignment operator and the destructor, they are not inherited, the default versions of these classes are okay. That's why I'm not writing any of them. But the constructor I have to write. Without writing the constructor, things don't get initialized, and that's going to be a problem for this class. That's why we write constructors. Okay, so good. Okay, constructors and derived classes, they are not inherited, and we will write our own. And when we are writing our own constructors, okay, we must initialize all the base class member variables, but to initialize all, it is not our job. I just call directly the constructor of the base class. The constructor of the base class. Good. And this is how I do it. With the hourly employee, this is a constructor that takes 1, 2, 3, 4 parameters. And I am sending the first 2 parameters to the base classes constructor. I am sending the first 2 parameters to the base classes constructor because they are not related to they are related to the base class. I will not deal with them. I will reusing its base classes code in this case, but this wage and hours is something new. I have to deal with them. Okay, and nicely the syntax says that use the member initialization section. Remember, this is what we have been doing so far since the beginning of the semester. Initialization of the data members. Okay, member initialization. This is something a little bit new. We are calling the base classes constructor to initialize the base class part of our object. Remember my picture. If I have a, let me try to draw this. Hourly employee. If I have an hourly employee object, H1, name is Ali Yilmaz, and SSN is 1, 2, okay, 7, very small one, and I have 2 more things. I think the rate, wage rate, let's say it is 50 Turkish liras per hour, and I have worked 20 hours. Okay, if you look at the H1 in my memory, it's going to be like this. I think I drew a similar picture yesterday. So I have 2 parts in my object. In second part, I have this rate, wage rate, and the hours. Wage rate is 50 and hours is 20. And inside my object there is an employee object actually. Employee, and employee has three parts, right? The name, SSN, and net pay. Okay, and the name is of course Ali Yilmaz, and SSN is I think it was something like this. And net pay, I did not look at the implementation right now. Net pay is some kind of a double. I think it is going to be 50 times. Net pay is going to be 50 times 20. Okay, so it's going to be 1000. So this is how my memory looks. So why am I drawing this one? I am drawing it because each of those data members is my data member and somebody has to initialize it. Okay, somebody has to initialize it. Who is going to initialize this part? Who is going to initialize this green part? This green part will be initialized by this base class constructor. Okay. How about the red part? The red part will be initialized by these two initialization statements. Okay, so all the object is covered. All the object is covered. What happens if I don't call the base classes constructor? Then the compiler will automatically call the base classes default constructor, no parameter constructor. And remember, what does a no parameter constructor do with the employee object? Can anybody remember? What does the base classes default constructor do?
It assigns empty string, I think.
Yes, exactly. It assigns empty string to the name and the social security number. And for the net pay, it assigns 0. So if you don't call this, okay, your employee object inside your hourly employee object will be initialized those default values, and that will be bad for you because you're gonna lose this Ali Yilmaz and this 1, 2, 3, 4 thing. Okay, so that's the default behavior. So if you forget to call the base classes constructor, it's not a syntax error. The compiler will say that, okay, I am going to call the default or the no parameter constructor of the base class. Your object will be initialized one way or the other. Okay, if you don't initialize it, the compiler will initialize it, and you may not, most of the time you may not like that initialization of the compiler. Okay, an hourly employee. Okay, in this case, hourly employee no parameter constructor. In this case, I am calling the base classes no parameter constructor. If I don't call this, what happens? It would be exactly the same because the compiler will automatically call base classes constructor. So doesn't matter if you write this here or not, it will be exactly the same. But the correct thing is this: doesn't matter if the compiler is going to call it or not. Okay, doesn't matter if the compiler is going to call it or not. Just write it here so that people wouldn't think that you forgot something. Okay, it's a good idea to call the base classes constructor all the time. Okay, you should always invoke one of the base classes constructors. Don't let the compiler initialize stuff for you. That might confuse your readers. That might confuse yourself later, maybe, when you read your code. Okay, good. Okay. So if you do this, If you do not the base classes constructor will be called, it will be exactly the same. This code and this code will be exactly the same, but we don't like this code. Okay, because it looks weird. It looks weird. Okay, let's look at this one. This kind of surprises people. And they say that, well, you told us that way, now you are telling the other way thing. But it is not actually. It is a very logical explanations for it. But it looks like I am out of time. I am out of time, and let's take 10 minutes of break. Okay. After the break, we will continue with this private data of the base class. Okay, 10 minutes of break. We will be here around 32. Okay. Okay, so what we said from the beginning is if you are inheriting from a base class, whatever the base class has becomes yours, right? Because you are inheriting it. So that's why we could say that, remember this code that I have written, okay? The base class has get, net pay, get name, etc. Though the salaried employee will have the same thing. I can call those functions because I have inherited that. And we said that the inheritance applies for both the data members and the function members, doesn't matter. So you might think that if it is the case, let's implement this salaried employee thing. Let's say, although it's a bad thing, let's say I want to do it this way. I am not going to use this member initialization stuff. Okay, put it in there. Okay, I'm erasing it. I will say that my salary is going to be, okay, my salary is going to be new, okay, this, and then my, what was the, okay, name SSN, right, and net pay, okay, and my name is going to be, new name, and my SSN is going to be new number, and my net pay is going to be 0. Okay, so I am not using any base classes constructor. I am not using the member initialization. I said that I am going to initialize everything myself. I know it better. Okay, and you try to compile it, and this one works. Okay, this is okay, no problem, works. But these three lines will produce you a compiler error. They will say that, the compiler will tell you that name, SSN, and net pay are private data members. Name, SSN, and net pay are private data members of the employee class. Okay, and you are not part of the employee class. You are not part of the employee class, and this code will produce syntax error. But I mean, remember all the pictures that I showed you, the pictures that I drew here, we kept saying the same thing. Okay, we said that if you are an hourly employee, there is an employee object in it. Yeah, that's true. I didn't lie to you. That's true, but this is also true. This one. This will produce a compiler error. The reason for this is, although you inherit all the private data and function members, you are not allowed to use them. Okay? Right class inherits private data variables, and private function members, no problem. But you still cannot directly access them. Okay? You still cannot access them. If you like to change the private data members of the base class as a derived class, you need to use the public member functions like the setters and getters. Okay, so instead of doing this, you need to do, okay, these are all bad. That's why I am going to do this. Okay, these are all bad stuff. Compiler error. Instead, what am I gonna do? Instead, I will say set name and new name and set SSN and new number, and I think set net pay. Yeah, I think this one. Set net pay is going to be 0. If you like to do it this way, you have to use the public interface. Okay. So this kind of surprises people, saying that, okay, how come I cannot access something that I have, that I own? Okay, I know that I inherited them. I know that in my objects there are these data members, but still I cannot access them. The reason is this. Okay, the reason is this. Remember, the class employee doesn't know that anybody is inheriting from it. The class employee doesn't know anything about this. So what does that mean? It means that I have written my class employee in a way that my private is my private, and I know that nobody else is going to access these name, social security number, and net pay. I know this. So that's my assumption. By using this assumption, maybe I have written some code. I mean, if I am violating that assumption with the right classes, then my class, my base class might be broken, because when I am writing the base class, that was my assumption, and somebody is violating my assumption now. I cannot let anybody do that. Okay, so that would be a hole in the encapsulation and information hiding principle. So this is the right way of doing stuff. You cannot access the private members, data members or the function members, doesn't matter. You cannot access the private members of the base class directly. You have to use the public interface, even though you are deriving from that class. Okay, because the base class doesn't know that you are deriving from it. Base class, I mean, since you are deriving from base class, doesn't make you a friend of the base class, because base class didn't let you become a friend of that class. Okay, so that's the reasoning. Okay, any questions about this? Any questions about this private data? So that means that you are gonna do the public interface, and that might make things a little bit inefficient for some cases. And sometimes you need to have the access to the private functions. Well, that's not going to happen. I mean, sometimes private functions might be useful for you, but those are private. Private means private. Nobody can have access to them. Not even the right classes. Okay, any questions? Understanding this rule is important. Understanding why they didn't let this access is important, and understanding that even though I have this data, employee data, inside my object H1, I cannot access them directly, is something fundamental in object-oriented programming world. And this is the right decision. They made the right decision in not allowing them doing it that way. Okay, good. But when C++ first came out, okay, when C++ first came out, this was the decision. This was the right decision. Later, people started talking about this is too restrictive. I like to be able to access to the base class's private data. And when you tell them that use the public interface, no, that's too inefficient, and I like to do this and that and that and that and that. Then they came up with this solution, and they added this later. Okay. Okay. They say that, okay, I will give you another qualifier, access qualifier. Other than public and private, there will be a protected qualifier. So the class will have three parts: public part, and the private part, and the protected part. Protected is another C++ keyword. Is the third qualifier. We don't have anything else. Okay, public, private, and protected. okay? And if you declare a member function or a data member under the protected section, it is like a private for the outside world, but it is like a public for the derived classes. Okay, so it is in between public and private. It is private, it behaves like a private for the outside world, but it becomes public for the derived classes. So derived classes will have direct access to the protected data members and the function members. Okay, but some people say that no, this is not right. This violates the information hiding principle. This is like using a friend function, or this is like exposing your internal data. But this is kind of, again, like friend function. You only allow it for the derived classes. Okay, so protected is our third qualifier, and it works that way. And let me show you how it is done. What you do is you just go there, and instead of private, you just type protected. Okay, so if I do it protected, okay, then my salary the employee, this code will work now. Okay, this is a compiler error with private, but okay with protected. Okay, this one is always okay. So the best solution is actually this line 21. Okay, line 21, just do it that way. This is the desired solution. This is the right way to it. But for some reason, you need the access to the base classes, private data, you are not allowed. If you need those kind of stuff, instead of private, use protected. Protected. Okay, so did I miss anything here? I think I talked about everything. Cannot be accessed outside the interface. Okay. Private is private, no exceptions. That's good. Protected is between public and private. Okay. And we say that this is reasonable, because the private should be simply private and nobody should have access to it. Because when I write my code for the base class, I assume that I am the only person who can have access to these private data and functions. That's my assumption. If somebody modifies that data, maybe my code will be broken. I don't know. Okay, so protected is kind of in between. Okay, good. So I think this is the second thing that I have introduced as syntax-wise with the inheritance. Okay, one is how you do the inheritance. The other one is calling the base classes constructors. And the third one is this protected qualifier. Not many things to remember, but with each one, there are certain issues. For example, why they needed this protected, why it was needed, etc. Why they needed it? Because, as I said before, some people said that I need to have access to the private data, but no, you cannot. But I need to. I mean, I don't want to make everything public. That would be a very, very bad decision. You don't want to make everything public. Okay, so what am I going to do? Okay, keep some stuff protected. By the way, this doesn't have to be. Okay, you may have at the same time private section 2. Okay, so in a class, you may have 3 sections: public section, protected, and private section. That's okay. You can do that. Okay, so when you are writing your code of the employee, you know that nobody outside of the class can have access to these section, protected and private. But you also know that the protected section could be accessed by the derived classes. Okay, good. Let's look at this idea of redefinition of member functions. Remember, you don't redefine your member variables. Only the member functions are redefined. Okay. Remember the interface of a class. Okay. Interface of a derived class is it contains the declarations for new member functions. Okay. Also contains the declarations of the functions that are going to be changed. So inherited member functions not declared, they are automatically assume that they are not going to be changed. So if you are declaring something in your new class that belongs to the base class, that means that you are going to redefine it. Okay, you will redefine it. Okay, so you define new member functions and you redefine the inherited functions as declared. And I think this one was asked before, redefinition versus overloading. Okay, they are very, very different. Okay, redefinition, as the name implies, okay, is a new definition for an already existing function. You are replacing the old definition with the new one. With the overloading, you are adding a new definition. You are not replacing it. So old definition stays. You say that this is also valid. Okay. With the redefinition, you use the same parameter list. With the overloading, you use a different parameter list so that I can differentiate between different calls. Okay. So they are very, very different. And if you start doing things like you are doing both redefinition and overloading at the same time, that's not a good idea. That's not a good idea. That will confuse lots of people. So don't overload redefined functions. Don't overload redefined functions. That will be confusing because you will not know whether it's a redefinition or it's an overload by looking at the code. So if there is a possibility that you are gonna redefine something, don't overload it. Don't mix them together. That's going to be bad. Okay. By the way, I did not look at the code of the hourly employee. Hourly employee CPP is like this. Okay. Hourly employee says that I will call the base classes constructor. I will call the base classes constructor. I will add 4 new setters and getters. And print check is, okay, it's something like this. It says that, okay, this is different. But it looks like, did I see, okay, I think this is not the correct version of the employee. Employees is going to be different. Let me copy and paste this from the salary the employee.h CPP. Okay. I copied the wrong code maybe. Okay, this is the code for the base classes print check. Okay, it says that I am going to get the name, net pay, and SSN. I will print everything. And then hourly employee is doing this. It says that I am going to set the pay to hours time wage rate. Okay, this is something that I can use because set net pay is a public function. And then I am going to call the employees print check. Oh, this is something new. Okay, this is something new. Why it is new? It is new because I am redefining print check of hourly employee. I am redefining the print check of hourly employee, but I am calling, while I am implementing it, I am calling the base classes print check. That's something new when we can do this. So with the redefinition, you are allowed to and you are encouraged to use the base classes functions. Okay, and I am calling the base classes print check because the base classes print check function is nice. It prints the name, it prints the net pay. I set the net pay, see, and it prints the social security number. And after that, I am printing all that information. I am printing new stuff like you worked this many hours and this is your net pay. Okay. So this is how the print check works. This is how the print check works for the hourly employee. Maybe we could do the same thing. We could do the same thing with the salaried employee. With the salaried employee print check, let me here. Let me do it. Okay. Set net pay is going to be like that. And I will call the print check. And get rid of this one because the base class is already doing it. Salaried employee regular pay is this much. And this is the end of the print check function. So I am using the base classes print check function to do some base class related printouts. Then at the end I add this stuff, and instead of salary, get salary is better. Always using the public interface is better. Just try to use the public interface first. Although I could do it, but I don't wanna use the private data directly. Use the getter all the time. Okay. So when you are redefining a function from the base class, most of the time you're gonna call the base classes function that you are redefining. Okay. By the way, this is possible too. Look at this code. We don't use it, but this is possible. Not typical, but sometimes useful. So I have two objects. One is an employee, Jane. The other one is Sally, hourly employee. Okay. And I can, of course, I can call the Jane's print check. This will call the employee's print check. And this will call the hourly employee's print check, I know. But if I like to call the employee's print check on Sally, okay, employee's print check on Sally, I could do that using the binary scope resolution operator. Binary resolution operator. I could do that. Not typical, but I could do that. If that one is possible, how about this then? Can I do this? Color blue. Jane E. dot Can I do this? With the salary age, I did that. And I like to do this with Jane E.
Base class doesn't know hourly employee.
Yes, exactly. The base class doesn't know about anything. The base class doesn't know anything about the hourly employee. Hourly employee is derived from base class. It derived from the base class, and it knows about it. But base class doesn't know anything about the derived class. So this is definitely wrong. I cannot do that. This is definitely wrong. I cannot do that. This is a compiler error, but this is not. As I said before, the book says this is not typical, not used very often, but it is possible, just to show you that everything is inherited from a base class. Sometimes you use them directly, sometimes you cannot, but everything is inherited, including the functions that you are redefining. Okay? And it's a very common code. It's a very common code to write stuff like this. Call the base classes print check. Question. Instead of doing this, what happens if I do this? I am calling the print check directly.
Infinite loop, I guess.
Yeah, we will go into an infinite loop, not infinite loop, infinite recursion. And there is no such thing as infinite recursion. We will end up we will end up using all of our stack space, and we will get a out of stack space error, and our program will be terminated, right? So this is not a good code, because this is calling line 50 is calling line 45, and that's a bad thing. So this is a bad infinite recursion. Okay, so don't do that. Don't do this. The right thing is doing it that way. Good. Okay. As I said before, all the normal functions in the base class are inherited. Whether it is public or private, they are all inherited. But there are some exceptions. Constructors are not directly inherited. They are inherited, as I said before, but the base class's constructor is not your constructor. You have to write your own constructor. The base class's destructor is not your destructor. You have to write your own. The same thing for the copy constructor and the assignment operator. So these are the things that have default values, right? If you don't write a constructor, okay, there is a default constructor. If you don't write your destructor, your objects will be gone automatically if they are automatic. If you don't write a copy constructor, member-wise copy will be made. If you don't write your assignment operator, a member-wise copy will be made. So for a new derived class, all these four will be available, and if you don't write them your own, the default behavior will be executed. So most of the time, if needed, we are going to write them. Definitely you're going to write your constructors, but if you need the big three, definitely you will need to write your destructor, copy constructor, and assignment operator. Okay, so let's look at these assignment operators and copy constructors. Okay, when you are writing your own assignment operator, copy constructor, okay, you usually call your base classes copy constructor and assignment operator, because who is going to do the work for the base class part, right? So it's like the print check. I am going to do it that way. Okay. So this is usually what you do. Let's say let's say you have a class named base and you have a class named derived. Okay. And you are writing your assignment operator for the derived class. Okay. So you are saying that I am going to get another derived object by constant reference. And this is how you call your, first you call your base class's assignment operator with the right side, and then you handle the rest of the stuff yourself. Okay. Okay, I mean, even though we don't have to, let's try to do the same thing with our class. Let's say I am going to write the for our salaried employee, even though I don't have to. Okay, salaried employee reference. I am going to overload the operator assignment and I will need salaried employee reference other, right? I will overload this one. I don't need it. The default assignment works, but just to show you how it is implemented. And I will go to the salaried employees implementation file. And at the end of it, I will put it in here. Of course, it has to be part of the class, right? Like this. Okay. So what was the book's suggestion? The book said that write it this way. Call the base class's assignment operator and do the other stuff. Okay, I will call the base class's assignment operator. What is my base class? It is employee. Employees operator assignment, and I will say other. So this one handled everything about the base classes data members, including the social security number, name, and the net pay. And I will do the assignment of the set salary and other dot get salary. Nice. Okay, I'm done, right? Okay, so this looks simple, like the book says. It is very similar to what the book is suggesting. I wrote my assignment operator, and I let the base class's assignment operator handle all the stuff related to base classes data members, including the social security number, etc. The neat thing, I am doing it myself. But there is a kind of a problem here. Can anybody see the problem with these just 2 lines of code? There is something that you need to be careful about. I mean, this should make some concerns for some of you. Something weird, something you should say, well, this should not happen. How come this works? So this is the result of maybe the remote education thing, because whenever I write this code, the 4 or 5 people immediately jumps and they say that no, this cannot happen. What are you doing? This is wrong. This doesn't happen. So I am expecting you to ask that question now. This code, these 2 lines of code should surprise some of you, and you should be objecting to something here. What are you guys doing? Just sleeping? At the beginning of the class, I had only 13 people. Now I have how many? 60, 70 out of 150? I don't know. So nobody can see anything? Okay, let me narrow my question. How about this line 59? That you should be asking a question about this line 59.
I guess, sir, we are not assigned anything.
Say that again, Mohammed.
We are doing something, but we are not assigned salaried employee. We are using operator equation assignment operator employee, but we are not assigned to a pointer this or anything.
Oh, yeah, you mean that we did not return anything. Okay, maybe you are saying this. Return. Yeah, well, I was not saying this, but this is definitely correct. This is one thing, but I was not okay. This is now, I mean, what I did was before it was error. Yeah, I mean, yeah. No, I was not asking this. So I am returning this. No, I am asking about 59. So Mohammed is telling me that I made a mistake, so I fixed that mistake. Well, I didn't do that mistake on purpose. That was really a mistake. Of course, I should return something. Well, you guys even didn't notice it. Oh, well, okay. 59. You should be asking something about 59. Whose operator is this? Operator assignment. Whose operator is that?
Sir, can you see the chat?
No.
There are answers in chat, but
Well, I am
can't
not
see
reading
it.
the chat. You are supposed to use your microphone. I don't read the chat. I cannot see anything. For some reason, chat doesn't work from day to day. So what is wrong with 59? Okay, Yakup Talha Yolcu, you tell me what is wrong with 59? Yakup Talha?
I think we are using scope relation operator with operator overlating equal.
Yeah, that's not wrong. I mean, that's what book says, right? Book said that do it this way. And we already did that with the other function, so that's it's not a problem. We already did that with the print check, right? I use the employees print check, no problem. Okay, Shevval, you tell me. Yeah. Okay, Atakan, you are telling me something. What is wrong with?
We are using base class operator with inherited class object.
Yes, exactly. Base class operator assignment works on what? Okay, what is this operator for the base class? It expects an employee, a constant employee reference, right? It expects a constant employee reference, this one. What I am sending is a salaried employee reference. How come this works? These are two different classes. How come this works? Okay. The answer is no, this code is not wrong. This code is correct. This will work. Because the compiler knows that salaried employee derives from employee class, and each of the salaried employee objects can behave like an employee object. Okay, this is what the compiler knows. Okay, so this is one of the biggest advantages of inheritance. Base class objects and derived class objects. The compiler will think that each of the derived class objects can behave like a base class object. And we call this, there is a relationship between these classes. Each derived class object is a base class object. Each salaried employee object is a employee object actually. That's why let's say I have a function. This function needs a constant, or doesn't matter if it's constant or not. Okay, this function needs an employee object reference E. Okay, and let's say I have a salaried employee S1 and I have a hourly employee H1. I can call this function with S1 and I can call this function with H1, both of them, no problem. It will work. It will work because, as I said before, each salaried employee and each hourly employee is an employee, and the compiler knows about this. There is an is-a relationship. We did not talk about this, but this is one of the powerful ways of, this is one of the most flexible features of inheritance. Compiler know about the inheritance, and compiler says that, okay, whatever you derive from this class base, those objects of that derived class will behave like the base class. Okay, so this is what I'm trying to make the point of. Okay, good. So as I said before, I didn't have to write this operator assignment, but just to show you the idea, I wrote it. Okay, let's go back to our slides and let's continue. And that code calls the assignment operator of the base class. Okay, and of course, when you are writing the copy constructor, see, I am calling the base classes copy constructor. Again, the same thing. I call the copy constructor of the base class with the object of the derived class. Okay, I am calling the copy constructor of the base class with the object of the derived class because, as I said, this object is an object of the derived class, also it's an object of the base class. That's why we keep saying stuff like that, okay? That's why we keep saying stuff like this. There is an employee, okay. Let's say this is a set, küme, of employee objects. There are many employee objects, tens of thousands of them. Some of them are hourly employees, and some of them are, okay, salaried employees. Okay. So these are the objects of the employee class. Some of them are both hourly employee objects and the employee objects. Some of them are salaried objects, salaried employees and employees. Okay, this is a diagram that we draw a lot, and the meaning of it is this actually. And the compiler knows about this picture. Okay, compiler knows that. Let me use the green. Okay, the green objects are both hourly employee and employee, and the red objects are salaried employee. Also, they are employee too. The blue ones are just employee. Okay, they are just employee. So this picture, the meaning of this picture is really that, and the compiler knows about this fact. So the argument is valid. Object is of type derived, but it is also of type base, and the compiler knows about this. Okay, good. Any questions so far? I cannot read your chat comments. That's a good thing. If you have a question, just use your microphone. How many messages are there in the chat window?
Sir, can someone be a hourly employee and at the same time salaried employee?
Both at the same time hourly employee and salaried employee. Can someone?
Yes.
No, because it is the same thing as saying I have a double D, I have an integer I. Can I have a variable that can be both double and integer? Can I?
No, we can't.
So it is the same thing. No, you cannot. But
Okay.
but if you do something like this, employee, okay, this is your employee, and this is your hourly employee class, and this is your salaried employee class. If you write a new class, salaried hourly employee class, and it derives from both of them at the same time. So the objects of this class is both objects of hourly employee and salaried employee, also at the same time an employee. So you need a new class for that, okay? You need a new class. You need to make a new class, and you need to make objects of that class. So let's say I have a function that takes an employee object. I have another function that takes hourly employee objects. I have another function that takes salaried employee objects. Let's say I have salaried hourly employee object 1. I can call this function with F, with G, and with H, object 1. Because object 1 is an object of both salaried hourly employee, salaried employee, and employee. Okay?
Thank you, sir. I got it.
So for that one, you need to use multiple inheritance. But as I said before, there are some certain details about multiple inheritance, and we need to be careful about it. Okay, any other questions that I did not respond from your chat messages? Okay, destructors in derived classes. I need to go on a few more minutes because I started kind of late. Destructors in the derived classes. If the base class destructor functions correctly, okay, it is easy to write the derived class destructor. Okay, you don't call when you are writing the derived class destructor, you don't call the base class's destructor yourself. It is called automatically. Okay, it is called automatically, and you need to be careful about this. It is not like the constructor. With the constructor, you call the constructor yourself, right? Okay, if you don't call it, it is called automatically, but with the destructors, you never call the base class destructors at all. Okay, they are called automatically. So let's write a simple class hierarchy, and just to show you, okay, here is my class. Let me write this here, very quick. Class A, very simple class, public. This is my constructor. The constructor will not do anything. It will just print out cout a constructor. Okay. And let me write a destructor for this one. Cout a destructor. And that's it. This is a class. And let me write another class. Let me make this, okay, B, so that it becomes a base class, and the other one is going to be derived class. Okay, this is class base, and these are B's, base class. Let me write this derived class, DE, public B, and public derived classes constructor DE. Okay, and I am going to call the base classes constructor, and then cout the constructor. Okay, and then I have the destructor of this one. It will call cout the destructor, and that's it. So I have written two classes, a very small hierarchy, a class B and a class D, base and derived, like that. Okay, let's say in my function main, okay, I have an object B and I have an object D. Okay, so let's see what kind of printouts I would get out of this two lines of code, just two lines of code. Okay, when I do this line, when I make an object of class B, base class, when I make an object of base class, of course its constructor will be called. And now let me write the printouts in green. So it will print out B constructor on the screen, right? That's what I know. Okay. After that, now that I have an object on my memory, and B, its name is B, and it lives. After that, I am making a derived class object D. Okay. The derived class object D is calling the no parameter constructor here, and the no parameter constructor say that I am going to call the constructor of the base class, right? So it will write B constructor again, right here. And after that, it will print this one out, the constructor. Okay, so I am done with creating my derived class object. And after that here, when I come here, the function ends, so these two objects are automatic and they will die. When they die, their destructors will be called. Okay, their destructors will be called. First object to die is the object D, derived object, right? Because it was created later. This one is going to be killed. So when it is killed, the destructor of the derived class will be called. So it will be the destructor. But this the destructor, after it is called, the base class's destructor will be called. So it will be B destructor. So these two lines, okay, these two lines come from the, can I do this maybe? Okay. And this line also comes from, okay, these two lines also come from the derived object. Okay. So when this derived object dies, the destructor of the derived class and the base class's destructor will be called in this order. When I am killing this one, okay, the base class's destructor will be called. Okay, so this is the order. So when you make a derived class object, okay, before the derived class's constructor starts working, the constructor of the base class object will be called. Okay, after it is done, the base class's constructor will complete. When it comes to the destructor, okay, the derived class's destructor will be called, then the base class's destructor. Just the opposite order, right? Just the opposite order. So order is like this one corresponds to this one corresponds to this one. And of course this one corresponds to this one. And it makes sense because if you are clearing up your memory, it has to be that way. Okay, good. Any questions so far?
What happens we don't use inherited class constructors? We don't use base class constructors with inherited class constructors. Still, we call base class destructors.
You mean what happens if I don't make a call here?
Yeah, still we
Yeah,
can
well,
call,
I mean, what was the rule? Remember the rule? The rule is if you don't call the base class's constructor, the default constructor of the base class will be automatically called. Since the default constructor, no parameter constructor is this one, the result will be exactly the same. Okay?
Okay.
Okay, any other questions? If there are no questions, we will continue on Monday from this point and study hard for the midterm exam. Okay, I said that inheritance will not be included in the midterm exam, but I mean, it looks like people are not attending the classes because this is not covered in the midterm exam, but we are talking about very important stuff here, right? I mean, we are talking about the destructors and the constructors and the calling order, that kind of stuff. You are learning about the other parts of the object-oriented C++. Okay, you are kind of reviewing it. You are making sure that you know some stuff. So attend the classes and be very careful and try to learn as much as possible. Okay, and it will be difficult to catch up later. Again, inheritance is something important. Okay, that's it for today, and we will continue on Monday.